Hi everybody. This is another word problem example where you're given the equation and then asked to answer questions in the context of this problem. I often don't get to this one in class, so if you're feeling comfortable, absolutely go ahead and give this one a go and then come back and check your answers. But I figured I've got it here in my just in case I'm speedy, so I'll post it for all of you guys. I think the first thing that stands out to me here is that this is in vertex form, so that means I'm going to get some information for free in this situation that I would not have been able to get quite so easily if I was in standard form or factored form, the vertex in particular. So before I even read anything, I look at this and I can see that the vertex is at 4831.7. Okay, so let's actually get into what this is talking about. This is supposed to be modeling the fuel economy, E, in miles per gallon of a sedan as the function of the speed s that it is traveling at in miles per hour. So if it's going s miles per hour, it's getting e miles to the gallon. Find a reasonable domain and range for this function. I think right off the bat we've hit kind of a funny one because I'm certainly not the expert on fuel economy. So again, I just want to emphasize the fact that when I ask you for reasonable domain and range, I'm not trying to get you to give me some expert answer about fuel economy. I'm trying to get you to look for the extremes. This clearly doesn't make sense. I'm going to leave it out. Those sort of things. So here, I'm going to say that we don't want to look at negative speed, although I will point out that you can have negative velocity. That just means going the other direction. But if I've got some parabola opening down, then at some point, I don't know where, I'm going to cross the y-axis. And this is going to say that if I slow down and then stop and then start going negative speeds, going backwards, that my fuel economy keeps dropping, which seems like garbage to me. So I think we definitely want S to be greater than or equal to 0. So I'm not going to look at negative speed. On the other end, I got like an accent there. On the other end, I feel like the x-intercept might be kind of useful. So let's go ahead and find it. You can also double check this on your calculator to poke around a little bit, but I'm just going to do the algebra. It's really good practice. So let's let this equal 0. Okay, so I'm going to subtract the 31.7. Again, vertex form always sets you up really nicely. Oh, 31.7. Equals negative 0.009. Sets you up really nicely to use square roots to solve. Okay, and then I'm going to divide by this 0.009. See if I can get this right. 31.7, there we go. Over, and the negatives cancel out. So I'm going to go ahead and do that. Otherwise, I would say don't build up a bunch of rounding error. Just keep the fraction there. So if there's something really easy to do, like cancel out the negative signs, go for it. But save up the calculator part until you're all done so that you don't get rounding error compounded on rounding error. Okay, and then I'm going to square root both sides. So I have a plus or minus the square root of 31.7 over 0.9, make sure I'm not losing decimals again, equals s minus 48. Okay, so I get s equals 48 plus or minus the square root of 31.7 over 0.009. 9 thousandths. Okay, so this becomes a great calculator problem. Now I think is the appropriate time to grab your calculator. So I'm going to do 48 plus the square root of 31.7 over. Okay, so there's one possibility, 107.35. And then I'm going to snag that answer and just switch it to a minus. Again, if your calculator doesn't let you arrow up and snag your last answer, you could try just hitting second enter if it's one of these TIs, and that will bring up the last thing that you typed out. So negative 11.35. Okay, in terms of what's reasonable, I don't want to see that one. That doesn't make sense. I was looking for this end. So I would say the very biggest possible thing you could give me for the other end of your reasonable domain is 107.35. Anything beyond that is definitely garbage because it's going to give you negative fuel economy. I would be completely comfortable with somebody wanting to cut it off a little sooner, because what that is saying, that 107, in fact, I'm even going to take this off. If you hit the 107.35 miles per hour, that's saying that's an x-intercept, your fuel economy is 0, which does not seem reasonable. So it should be cut off somewhere before that. If you want to actually play around and plug in some numbers and figure out somewhere that you think seems a little more reasonable, go for it. Again, I'm not looking for you to be experts on fuel economy, but I am looking for you to notice things like negative fuel economy doesn't make sense, negative speed doesn't make sense. Even in this case, I think 0 fuel economy doesn't make sense. So it's okay to be a little bit unsure about exactly where to cut it off, but look for those really glaring, this has definitely got to be a cutoff. What speed should the car travel to maximize fuel economy? This is one where we don't have to do much work. Right at the beginning of the problem, I said that my vertex was 4831.7. So in my picture, because again, this has a negative number out in front, it's going to be opening down. So that's a maximum. That's saying that if my speed is 48 miles per hour, my fuel economy hits its highest point of 31.7 miles per gallon. So the car should be going 48 miles per hour if they want to maximize fuel economy. So with all these quadratic functions, word problems, we get the usual stuff. We should be able to find intercepts, think about reasonable domain and range, that kind of stuff. And then we get this extra piece where parabolas have a maximum or a minimum. So we can talk about the maximum or the minimum of whatever we're looking for in the problem. Part C, what is the maximum possible fuel economy? Again, we've already figured this vertex out, so we've got the answer. It's 31.7 miles per gallon. No work needed for something like that. I'm hoping in a problem like this that you recognize that you have vertex form and you just get that vertex for free. So if you space out and you do a bunch of work to get it, fine, hopefully you get the right thing. But again, my hope is that you're learning to watch for information that you can get out of the form that your equation is written in. Okay, and the last one here, we'll see if this one is less confusing than the deer. I'm not confident it will be, because whenever your variables represent rates, the rate of change of a rate is a little bit tricky, but we'll try it. So from s equals 50 to s equals 60, we want to find the average rate of change and then explain what it means. Average rate of change is a slope, so we're going to have to plug in the 50 and the 60 to figure out our y-coordinates. Okay, so what do we get here? We get 50 minus 48, which is 2. And then we get 60 minus 48, which is 12. Okay, so let's go ahead and ask the calculator. Negative 0.009 times 2 squared is 4 plus 31.7. Your calculator will absolutely do that square for you, but when I can do little bits of the arithmetic, I try to. Oh, interesting, we got back almost what we started with. I'm going to go ahead and keep the 2 decimals, 31.66. What we started with, we got almost our vertex back. And I guess that makes sense because we were very close to that best possible speed. And then same thing, but I don't want 4. I want 12 squared, which is 144. So this is 30.40. Okay, so now I've got 2 points, 50, 31.66, 60, 30.44. I want to calculate the slope, so I'll take 31.66 minus 30.4 over 50 minus 60. Okay, the bottom is 10. Let's see if I can do decimals in my head today. 30.4, 31.4, so it's a 1.26. I believe. We will double check me, because sometimes I can't be trusted with these things. 1.26, and then if we divide that by 10, it's going to become 0.126. Okay, so units on this thing. This was fuel economy, so miles per gallon, as a function of speed, miles per hour. So this is change in y, miles per gallon, over change in x, miles per hour. So I would say, and again, there's kind of a lot of info in here, if you're talking about speeds between 50 and 60 miles per hour, increasing your speed by 1 mile per hour is actually, ooh, hold on, I don't believe myself, this was a -10, wasn't it? Okay, there we go. And I'm going to put that negative out in front because I would much rather associate it with the top than the bottom. Okay, so let me try again. If you're traveling between 50 and 60 miles per hour, increasing your speed by 1 mile an hour will decrease your fuel economy by about 0.126 miles per gallon. Again, you could also say increasing your speed by 1 mile per hour will decrease your fuel economy by 0.126 miles per gallon on average, something like that. This isn't perfect. If we're picturing the graph of this thing, what did we do? We went like this. So we went from 50 to 60. We're over here. So we're calculating the slope of a line. It doesn't perfectly match up with the curve of our parabola, but it's decent. So approximate, but not exactly right on. Okay, thank you for watching.